Hello everyone, welcome to today's class. We will be learning about the switching operation of centrifugal pumps. During the operation of centrifugal pump, faults are inevitable. When encountering faults that cannot be resolved, it is necessary to switch between the main pump and the standby pump. First, we will introduce the common faults of centrifugal pumps, their causes, and handling methods, followed by the switching operation of centrifugal pumps. The first common fault of a centrifugal pump is pump cavitation or failure to deliver liquid. The cause is the occurrence of air binding. The handling method is to reprime the pump and expel the air, and if necessary, check whether the connecting bolts at the sealing surfaces of the inlet pipeline are loose, and whether the gaskets are damaged. The second common fault of a centrifugal pump is insufficient flow and head. The causes are cavitation or blockage by debris in the pipeline. The handling method is to check the liquid level in the raw material storage tank and repair the pipeline to remove the blockage. The third common fault of a centrifugal pump is vibration and noise. The causes are loose anchor bolts, misalignment of the bearing and pump shaft, or cavitation noise. The handling method is to tighten the bolts, adjust the center of the bearing and pump shaft, and eliminate the effects of cavitation. The fourth common fault of a centrifugal pump is leakage at the seal. The causes are insufficient sealing liquid pressure, damaged sealing rings, or imbalance in the rotating parts. The handling method is to adjust the hydraulic pressure, replace the sealing rings, and eliminate the imbalance. The fifth common fault of a centrifugal pump is excessive heating and inability to rotate. The causes are pump cavitation, increased friction in the rotating parts, or bearing damage. The handling method is to stop the pump for maintenance of the rotating part, add bearing lubricant, or replace the bearing. The sixth common fault of a centrifugal pump is high current. The causes are bearing damage, high rotational resistance, excessively tight packing seal gland or mechanical seal spring compression or scaling on the impeller, causing high resistance. The handling method is to replace the bearing, adjust the tightening nut or spring compression, and clean the impeller. The seventh common fault of a centrifugal pump is excessive pressure fluctuation. The cause is blockage of the foot valve or inlet filter. The handling method is to clear the foot valve and clean the filter during the switching process of centrifugal pumps. It is essential to ensure that the flow rate and pressure in the pipeline system experience minimal fluctuations and to strictly avoid cavitation and flow competition. Next, we will watch a video on the switching operation of centrifugal pump. In a circulating system transporting normal temperature water, the currently operating pump A has encountered a general fault and needs to be switched to the standby pump B. Pump A is a packing seal centrifugal pump, while pump B is a double mechanical seal centrifugal pump. First, pre-start inspection and preparation for pump B. Check whether the anchor bolts of pump B are tightened, and confirm that the lubricant level in the bearing housing of pump B is between 1/2 and 2/3. Confirm that the inlet valve, drain valve, outlet valve, and vent valve of pump B are closed, and the bottom valves of the inlet and outlet pressure gauges are open. Check the side glass of the mechanical seal liquid siphon tank of pump B. Confirm that the liquid level is between 1/2 and 2/3. The pressure in the sealed liquid siphon tank is around 2 bar, and open the mechanical seal inlet and outlet circulating water valves to ensure the flushing water functions effectively. Under the premise of ensuring energy isolation, open the protective cover of pump B. Manually rotate the coupling in the direction of the impeller rotation for alignment check, ensuring it rotates smoothly and without jamming, generally rotating 5 times. Fully open the inlet valve of pump B. Open the vent valve of pump B 3 times consecutively to vent and prime the pump, then close the vent valve to fill the pump with liquid and prevent air binding. Second, start the motor of pump B and monitor whether the pump's outlet pressure is stable and meets the nameplate head, as well as the pump's vibration, sound, etc. Third, slowly open the outlet valve of pump B while gradually closing the outlet valve of pump A, maintaining a stable total flow rate until the outlet valve of pump A is fully closed. Fourth, stop the motor of pump A. Fifth, check the operation of pump B. Observe whether the inlet and outlet pressures and flow rate of pump B are normal. Listen for sounds. Use a vibration meter to measure vibration, pump casing, bearings, etc., and observe for any abnormal noises and vibrations. After some time, use a temperature meter to measure whether the motor and bearing temperatures are normal. Check whether the pressure in the mechanical seal liquid siphon tank of pump B is normal. Check for any leakage at the seal, etc. Sixth, close the inlet valve of pump A. Seventh, open the drain valve of pump A to empty the residual liquid in the pump, then close it. Through this lesson, we have mastered the common faults of centrifugal pumps, their causes, handling methods, and the switching operation. Now, we will consolidate the knowledge learned today through a few exercises.